Hello there, and welcome back to Astro Dreams. I'm so glad you found your way here tonight. Perhaps you've had a long day, or maybe you're simply drawn to mysteries, to questions that linger at the edges of what we know. Either way, you're in the right place. Tonight, we're going on a journey unlike any other. We're going to follow two visitors from beyond our solar system, two travelers that came from the darkness between the stars, Oumuamua and Comet Borisov, objects that crossed unimaginable distances just to pass through our cosmic neighborhood. Brief, silent, and profoundly mysterious. You have nothing to do right now but rest. Let your breathing slow. Let your thoughts drift. Feel yourself settling into comfort, as if the universe itself is cradling you gently. Because tonight, we're going to explore one of the most intriguing mysteries in modern astronomy, the mystery of interstellar visitors. What they are, where they came from, and what they might tell us about the universe beyond our sun. Before we begin, if these peaceful explorations help you relax or bring you a sense of wonder at the end of your day, please consider subscribing to Astro Dreams. It helps others discover these cosmic journeys too, one dreamer at a time. Close your eyes, take a deep breath, and let's drift together into the mystery of interstellar space. In October of 2017, astronomers were scanning the sky, doing what they do every clear night, watching, measuring, cataloging, when something unusual appeared in their data, an object moving through our solar system. But this object was different. Its trajectory was wrong. It wasn't following an elliptical orbit around the sun like comets and asteroids do. Instead, it was moving in a hyperbolic path, coming from outside our solar system, passing through, and then leaving, never to return. This was Oumuamua, the first confirmed interstellar object ever detected passing through our solar system. Its name comes from Hawaiian, meaning scout or messenger, the first to arrive from a distant place. And it was everything we didn't expect. When astronomers first spotted Oumuamua, it had already passed its closest point to the sun and was racing outward, back toward interstellar space. They had only weeks to study it before it became too faint and too distant to observe. In that brief window, they gathered as much data as they could, and with each observation, the mystery deepened. Oumuamua was tumbling through space, rotating chaotically. Its brightness varied dramatically as it spun, suggesting an elongated shape, unlike anything we'd seen before. Some estimates suggested it might be 10 times longer than it was wide, a cigar-shaped object, or perhaps a flat disk, like a cosmic pancake. We still don't know for certain. Its surface was reddish, similar to objects in the outer solar system that have been darkened and reddened by billions of years of exposure to cosmic radiation. This suggested Oumuamua was old, very old, an ancient traveler that had been drifting through interstellar space for millions, perhaps hundreds of millions of years, before passing through our solar system. But the strangest discovery came when astronomers analyzed its trajectory more carefully. As Oumuamua moved away from the sun, it accelerated slightly, a tiny, unexpected increase in speed. This kind of acceleration is normal for comets, which release gas and dust as they're heated by the sun. The outgassing acts like a tiny rocket engine, pushing the comet along. But Oumuamua showed no signs of outgassing, no tail, no coma, no cloud of dust. It looked like an asteroid, but it was accelerating like a comet. This unexpected acceleration sparked intense debate. What could cause it? Some scientists proposed that Oumuamua was made of unusual materials. Perhaps it was mostly hydrogen ice, which would evaporate without leaving a visible trail. Others suggested it might be a fragment of a planet torn apart long ago. Still others wondered if the acceleration could be explained by the pressure of sunlight pushing on its surface, if Oumuamua was thin and reflective enough. And then, inevitably, some wondered if it could be artificial, a probe, a spacecraft sent by a distant civilization. Most scientists dismissed this idea as unlikely, but the question lingered because Oumuamua was so strange, so unlike anything we'd encountered before. And because it came and went so quickly, we'll probably never know for certain. By early 2018, Oumuamua was gone, fading into the darkness beyond the reach of even our most powerful telescopes. It's still out there, somewhere in interstellar space, continuing its journey through the galaxy, a mystery wrapped in silence, carrying its secrets with it. But Oumuamua taught us something important. It taught us that interstellar objects pass through our solar system, that the space between stars is not empty, but filled with wanderers. Fragments of planetary systems, ejected worlds, ancient relics drifting through the cosmic void. And if we're watching carefully, we can catch them as they pass by. And we didn't have to wait long for the next visitor. In August 2019, just 2 years after Oumuamua, an amateur astronomer named Gennady Borisov spotted something unusual through his homemade telescope in Crimea. Another object, moving in another hyperbolic orbit, another interstellar visitor. This one would come to be known as Comet Borisov, named after its discoverer. But Comet Borisov was different from Oumuamua in almost every way. While Oumuamua was mysterious and enigmatic, Borisov was familiar. It looked like a comet. It behaved like a comet. It had a coma, a glowing cloud of gas and dust surrounding its nucleus. It had a tail, streaming behind it as it moved through space. In many ways, Borisov felt like a comet from our own solar system, just visiting from somewhere else. Astronomers around the world turned their telescopes toward Borisov, and because it was discovered earlier in its journey, while it was still approaching the sun, they had months to study it. They analyzed its composition, its structure, its behavior, and they compared it to comets from our solar system. What they found was fascinating. Borisov's composition was similar to comets in our solar system, but not identical. Its coma contained water vapor, carbon monoxide, and cyanide, much like local comets. But the ratios were slightly different. Borisov had more carbon monoxide than most comets we'd studied. This suggested it formed in a colder environment, farther from its parent star, where carbon monoxide could freeze into ice. The nucleus of Borisov, its solid core, was estimated to be about half a kilometer across, small, fragile. As it passed the sun, the heat caused it to release gas and dust, just like any other comet. But there was something poignant about watching this happen. Here was a piece of another star system, formed billions of years ago around a distant sun, and now, briefly, it was lit by our sun, glowing, displaying its beauty to anyone watching, before returning to the cold darkness. Borisov's color was also notable. It was redder than most comets in our solar system, similar to Oumuamua. This reddish hue is thought to come from organic molecules, complex carbon-based compounds that have been altered by cosmic radiation over eons. It's a color that speaks of age, of long journeys through the void. As Borisov rounded the sun and began its journey back into interstellar space, astronomers watched it closely. They noticed that it was fragmenting slightly, small pieces breaking off from the nucleus. This is not uncommon for comets. The stress of heating, the release of gas, and the structural weaknesses in the icy body can cause fractures. But for Borisov, it was a reminder of fragility. This ancient traveler, survivor of millions of years in space, was slowly coming apart as it passed through our small corner of the galaxy. By mid-2020, Borisov had faded from view. Like Oumuamua before it, it slipped back into the darkness, continuing its endless journey. We'll never see it again. But the data remains, the images, the spectra, the measurements, all preserved, a record of a visitor from beyond. Oumuamua and Borisov have given us our first glimpses into the populations of objects drifting through interstellar space, and what we've learned suggests that these visitors are not rare. In fact, astronomers estimate that interstellar objects may pass through the inner solar system every year, perhaps even more frequently. We simply haven't been looking carefully enough to find them. Most of these objects are small, dark, moving quickly. By the time we detect them, they're often already on their way out. Oumuamua and Borisov were only discovered because we happened to be looking in the right place at the right time, and because they came relatively close to Earth. There are likely countless others that have passed through unnoticed. But why do these objects exist? Where do they come from? And how do they end up wandering between the stars? The answer lies in the chaotic early history of planetary systems. When planets are forming, the process is violent. Protoplanets collide. Gravitational interactions fling smaller bodies into eccentric orbits. Gas giants migrate inward or outward, disrupting everything in their path. During this tumultuous period, countless objects, asteroids, comets, and even small planets are ejected from their home systems entirely. Thrown out into interstellar space. Once ejected, these objects drift. They travel for millions, even billions of years, moving through the galaxy with no star to orbit, no sun to warm them. They are frozen, dark, silent. Some were ejected when their planetary systems were young, in the first few million years. Others may have been ejected later, after their systems had settled, by rare gravitational encounters or passing stars. Oumuamua and Borisov are likely examples of this. Fragments of planetary systems, cast out long ago, wandering through the galaxy ever since. And purely by chance, their paths intersected with ours. For a brief moment, we shared space, and then they were gone. The discovery of these interstellar visitors raises profound questions. If objects are being ejected from planetary systems all the time, then the space between stars must be filled with them. A vast, invisible population of wanderers. Some are asteroids, rocky, metallic. Others are comets, icy, fragile, and perhaps some are even more exotic. Fragments of planets, moons torn from their worlds, objects we can't yet imagine. In a way, the galaxy is not just stars and planets. It's also a sea of travelers, objects in transit, moving from one star to another, never staying, never settling, just drifting, eternally. Astronomers are now building better tools to find these visitors. New telescopes with wider fields of view, automated surveys that scan the sky every night, software that can quickly identify objects with unusual trajectories. In the coming years, we expect to discover many more interstellar objects, and with each one, we'll learn more about what lies beyond our solar system. There's something deeply moving about these visitors. They come from places we cannot see, stars we cannot name, planetary systems that formed in ways we may never fully understand. They carry with them the history of their origins, the composition, the structure, the scars of their journeys, and for a brief moment, they share that history with us, before returning to the silence. It makes you wonder, How many other objects have passed through our solar system over the billions of years of its existence? How many visitors came and went before we had telescopes to see them? And what stories might they have told if we could have studied them? Perhaps one day we'll send our own probes to intercept an interstellar object, to land on it, to sample it, to study it up close. Such a mission would be extraordinarily difficult. These objects move fast, and by the time we detect them, they're often already leaving. But it's not impossible. Engineers are already sketching out concepts, fast response missions, spacecraft that could be launched quickly and accelerate to match the speed of an interstellar visitor. Imagine what we might learn from such a mission. We could analyze the composition in detail, measure its structure, search for organic molecules, perhaps even find clues about the conditions around its parent star. It would be like receiving a message in a bottle, cast into the cosmic ocean long ago, finally opened. But even without visiting these objects directly, their mere existence is profound, because they remind us that our solar system is not isolated. We are part of a galaxy, and that galaxy is dynamic, full of motion, full of exchange. Objects moving between stars, carrying matter, carrying information, connecting distant systems in ways we're only beginning to understand. Some scientists have even proposed that life itself might travel on interstellar objects. This idea, called panspermia, suggests that microorganisms, hardy bacteria, or spores could survive the harsh conditions of space, protected inside rocks or ice. And when these objects pass through a planetary system, some might be captured, landing on planets, seeding them with life. It's a speculative idea, but interstellar objects make it seem just a little more plausible. If panspermia is real, then life on Earth might have originated elsewhere, carried here on an ancient traveler, a comet or asteroid that struck our planet billions of years ago. And if life can travel that way, then perhaps life is not confined to single planets or single star systems. Perhaps it's a galactic phenomenon, spreading, adapting, thriving wherever conditions allow. We don't know yet, but the discovery of Oumuamua and Borisov has opened new possibilities, new questions, and that's what makes them so exciting. There's also something poetic about these visitors. They are wanderers, nomads of the galaxy. They belong to no star, no system. They move through the cosmos freely, unbound. In a way, they are the universe's way of sharing itself, of redistributing matter, of connecting the distant and the isolated. Think about it. The atoms in Oumuamua were once part of a protoplanetary disk around a distant star. Perhaps they were part of a planet that never fully formed, or a comet that orbited peacefully for millions of years before being flung into space. Those atoms traveled across light years, through the cold, through the dark, and then, for a brief moment, they passed through our solar system, close enough for us to see, close enough to measure, close enough to wonder about. And now, those same atoms are traveling onward, heading towards some other part of the galaxy. Perhaps, in a million years, they'll pass through another star system. And if there are astronomers there, they might spot Oumuamua, and they might wonder, just as we do, where it came from and what stories it carries. It's a reminder that everything in the universe is connected, not by forces or fields, but by motion, by time, by the long, slow exchange of matter across the galaxy. We are all part of the same cosmic fabric, woven together by journeys like these. Oumuamua's unusual acceleration remains one of the great unsolved mysteries. Several theories have been proposed, but none are fully satisfying. The hydrogen iceberg theory suggests that Oumuamua could be made of solid hydrogen, which would evaporate in sunlight without leaving a visible trail. This could explain the acceleration, but hydrogen ice is rare and fragile. Could it really survive millions of years in interstellar space? Another theory suggests that Oumuamua is a fragment of a larger body, perhaps a piece of a planet that was destroyed by a collision or torn apart by tidal forces. If this fragment was porous and filled with volatile materials, it might outgas in a way that's difficult to detect, producing enough thrust to accelerate, but not enough to create a visible tail. Some researchers have proposed that Oumuamua could be held together loosely. A rubble pile, a collection of smaller pieces bound by weak gravity. When heated by the sun, the interior might release gas that escapes through cracks and pores. This would create acceleration without a visible coma. It's possible, but we don't have enough data to confirm it. And then there's the more speculative idea that Oumuamua could be a light sail, a thin, flat structure designed to be pushed by starlight. Such technology would be far beyond our capabilities, but not necessarily beyond the capabilities of an advanced civilization. If Oumuamua were artificial, it would explain the acceleration and the unusual shape and the lack of outgassing. But it would also raise far more questions than it answers. Most scientists remain skeptical of the artificial hypothesis, not because it's impossible, but because extraordinary claims require extraordinary evidence, and we simply don't have that evidence. Oumuamua's behavior is strange, but strange doesn't mean alien. The universe is full of natural phenomena we don't yet understand, and Oumuamua is probably one of them. Still, the question lingers, and perhaps it always will, because Oumuamua is gone. We can't go back and study it more closely. We can't send a probe to catch up with it. It's beyond our reach now. And that's part of what makes it so tantalizing. It came, it puzzled us, and it left, leaving us with more questions than answers. Comet Borisov, by contrast, was more generous. It gave us time, it gave us data, and it gave us confirmation that interstellar comets exist, that they're out there, drifting through the galaxy, and that sometimes they pass through our neighborhood. One of the most interesting findings from Borisov was its high concentration of carbon monoxide. This suggests it formed in a very cold region of its home system, far from its star. In the outer reaches, where temperatures are frigid and ices can accumulate. This tells us something about the architecture of its original planetary system. It had a cold outer zone, much like ours, and comets formed there, much like they did here. But Borisov also had differences. Its dust composition was slightly unusual. The grains were larger and fluffier than expected. This could mean it formed under different conditions, or that it experienced different processes during its long journey through space. Either way, it's a reminder that even familiar objects can hold surprises when they come from other star systems. Borisov's fragmentation as it passed the sun was also informative. It showed us that interstellar comets are fragile. They can break apart under stress. This means that the objects we detect are probably just the survivors, the largest and most stable fragments from much larger bodies that have already broken apart. For every interstellar comet we see, there may be dozens or hundreds of smaller pieces that we don't detect. This fragility also suggests that interstellar objects may not survive indefinitely. Over millions of years, they're eroded by cosmic radiation, heated by encounters with stars, disrupted by gravitational interactions. Some break apart entirely. Others collide with planets or fall into stars. The population of interstellar objects is constantly being replenished by new ejections and constantly being depleted by destruction. It's a cycle, a balance, a dynamic flow of matter through the galaxy. one of the most fascinating aspects of interstellar objects is their diversity. Oumuamua and Borisov were very different from each other. One was asteroid-like, the other was clearly a comet. This suggests that the population of interstellar objects is varied. Just as our solar system contains many types of bodies, asteroids, comets, trans-Neptunian objects, so too does interstellar space. Some interstellar objects may be rocky, metal-rich, similar to asteroids. Others may be icy, volatile-rich, like comets. Some may be fragments of differentiated bodies, pieces of cores or mantles from destroyed planets. Others may be primitive, unchanged since the early days of their parent systems. Each one is a unique sample, a snapshot of different conditions, different histories. As we discover more interstellar objects, we'll begin to build a statistical picture. How many are rocky versus icy? What are their typical sizes? What are their chemical compositions? This will help us understand planetary system evolution across the galaxy, because every object ejected from a system tells us something about that system's formation and dynamics. In the future, we might even be able to trace some interstellar objects back to their origins. By analyzing their trajectories and compositions, we could identify which star they came from. Imagine that, being able to point to a specific star and say, that object came from there. It would be like receiving a postcard from a distant world, a tangible connection to a place we can only observe from afar. There's also the possibility that some interstellar objects are from outside our galaxy, from other galaxies. This seems unlikely because the distances between galaxies are so vast, but it's not impossible. If an object were ejected from a star system in a neighboring galaxy, and if it had enough speed, it could travel intergalactic distances over billions of years. If such an object ever passed through our solar system, it would be extraordinary. A visitor from beyond the Milky Way, carrying information about conditions in another galaxy entirely. We don't know how often interstellar objects pass through the inner solar system. Estimates vary. Some suggest 1 or 2 per year. Others suggest more. The rate depends on many factors. How many objects are in interstellar space, how densely they're distributed, how fast they're moving, and how large our detection volume is. As our telescopes improve, we'll detect more, and with more detections, we'll refine our estimates. But even if interstellar objects are rare, their existence is significant. Because it means the galaxy is not static. It's alive with motion, with exchange. Stars don't exist in isolation. They're part of a larger system, a galactic ecosystem. And that ecosystem includes the wanderers, the nomads, the travelers between stars. Every interstellar object is a reminder of this. A reminder that we are part of something larger, something dynamic, something interconnected. There's a melancholy beauty to these visitors. They pass through our solar system so briefly, a few months, a year at most, and then they're gone, back into the darkness, back into the cold. We catch a glimpse of them. We gather what data we can. We ask our questions, and then we let them go, knowing we'll never see them again. In a way, it's like meeting a stranger on a journey, a brief conversation, a moment of connection. And then each continues on their own path, never to meet again. But the encounter leaves an impression, a memory, a sense of wonder at the vastness of the world and the countless lives and stories passing through it. Oumuamua and Borisov are like that. Brief encounters, moments of cosmic connection. And then they were gone. But we remember them. We study them. We wonder about them. And in doing so, we honor their journeys. The search for interstellar objects is still in its infancy. We've only confirmed 2, but the technology is rapidly improving. New telescopes are coming online. The Vera Rubin Observatory, with its wide field survey capabilities, will scan the sky every few nights. It's expected to discover dozens, perhaps hundreds of interstellar objects. Each one will be a new mystery, a new opportunity to learn, and with each discovery, we'll get better at studying them. We'll develop faster response times, better instruments, more sophisticated models. We'll learn to predict when and where they'll appear, and eventually, perhaps, we'll be ready to send a mission, to intercept one, to study it up close. That day is still years away, but it's coming, and when it arrives, it will be a milestone in human exploration. Not just exploring our own solar system, but reaching out to touch something from beyond, a fragment of another world, a piece of another story. Until then, we watch, we wait, and we wonder, because the universe is full of mysteries, and some of those mysteries, like Oumuamua and Borisov, come to us, drifting in from the dark, passing through, and leaving us forever changed. As you rest tonight, think about those travelers. Imagine Oumuamua tumbling through space, far beyond the orbit of Pluto now, moving steadily outward, silent, dark, alone, carrying its secrets. Continuing a journey that began millions of years ago and will continue for millions more. And imagine Borisov, also far from the sun now, its tail fading, its nucleus cooling, returning to the frozen state it knew for eons before it passed through our warmth. It too is alone, drifting, a wanderer between the stars. And imagine all the others, the ones we haven't seen, the ones that passed before we were looking, the ones that will pass after we're gone. A silent river of objects, flowing through the galaxy, connecting stars, carrying matter, telling stories without words. You are here, on a small planet, orbiting a medium star, in one corner of a vast galaxy. And occasionally, visitors pass by, reminders that you are part of something larger, something ancient, something beautiful. The universe is not empty. It's filled with motion, with travelers, with mysteries. And tonight, as you drift towards sleep, know that somewhere out there, an interstellar object is moving through the dark. And perhaps someday, it will pass through our solar system, and we'll be ready to greet it, to study it, to wonder about where it came from and where it's going. The journey continues for Oumuamua, for Borisov, for all the wanderers, and for us, all of us moving through space, through time, connected by the vast, slow dance of the cosmos. Sleep well, dream of distant travelers, and know that the universe is full of wonders. Some pass by quickly, others stay, but all of them, every single one, is part of the same story. The story of matter, of motion, of the endless journey through space. Good night from Astro Dreams. May your dreams be filled with stars and travelers and the quiet mysteries of the cosmos.